This is 8.1 part 2. So if you did not watch part 1, please go back and watch the first part of this, because now we're going to be applying some of those terms that we saw earlier in this section. So part 2 says determine whether the following methods produce a random sample. If it is not ideal, suggest a better method. So the first example is, I want to find out how much money did HCC students spend on textbooks last semester. So I will ask every student who goes into the Plant City bookstore how much they spend. Is this a great random sample? And the answer is no. It's a convenience sample. If I'm standing outside the bookstore, I'm just gathering people who are there. That is not a random sample. Remember, random sample means every single student has an equal chance of being selected. So what might be better to do is maybe place all of the people's student IDs in a random generator and choose students that way. Also, the other problem with this one is we're just getting the students who are purchasing their books at the bookstore. We're not getting the students who purchase their books through, let's say, Amazon or Chegg, and we're not getting the students who purchase them online. Okay, here's the next one. I want to find out what Americans believe should be the legal age to drink alcohol. A poll was conducted on the news website, CNN, Fox, MSNBC, and PBS. Again, this is not a random sample. For starters, we're relying on people who watch the following news sources. Okay? We're not talking about every single American. Again, when we talk about random sampling, is every single person equally likely to be chosen? And the answer again on this is no, because there's some people that do not watch CNN, Fox, MSNBC, or PBS. Okay, so here we go. The next section or next objective in here is talking about frequency distribution. So by definition, a frequency distribution table is used to organize raw data by listing each value with its frequency. Frequency basically means how many times a thing happens. Okay, so we're going to see an example here that deals with frequency distribution. Okay, the frequency distribution table below, so we're looking at this table right here. Just going to put a little highlighter on that. I'm trying to, at least. There we go. We're looking at the frequency distribution table that I just highlighted, and it shows the number of goals Samantha's hockey team scored during the postseason tournament. The data values are the number of goals. So this first column is data values. Okay, and then the frequency is how often those goals occurred. So we're basically just organizing the data. So what are we doing? We're looking at how many goals and how often they showed up in the postseason tournament. So for instance, if there was one goal by Samantha's hockey team, it happened twice. 2 goals happened 5 times. 3 goals happened 4 times, and 4 goals happened 2 times. And finally, 5 goals, which is a lot, happened once. So when I read that, I was reading straight across. So I was looking at this, and deciding, how many goals go with the frequency. Okay. The data items that we just looked at, which in this case was the number of goals, is a complete list. This is called raw data because I'm not really doing anything with it yet. I am just collecting data, so it's raw data. And by the way, with raw data, when we collect it, it is usually never in order, okay? So let's go ahead and check out an example to show you what, this really kind of looks like. So HCC marketing team polled students and asked them how many classes that were previously taken at HCC. Here are their responses, which is the raw data. All right, guys. So what I'm going to do before I construct this frequency distribution table is I am going to write down all the different numbers I see. I see an 8. I see an 11. I see a 6. A 12. That one's new. Whoops. I don't know what's going on here. 12. 6, 0. I see a 4. I'm just looking through the rest of these. We already have 8. We already have 12. We already have 6. We already have 11. In the second row, a new number is 9. And then we have 8. We have 6. 4 we have. 11 we have. And 8 again. Okay. So what I'm going to do is I'm going to make the tally mark. Okay. So let's look at 8. And I'm going to cross these out as I find them. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Let's look at 11. So 1, 2, 3, 4, 5, 6. All right, let's look at 12. 1, 2, 3. 6. 1, 2, 3, 4, 5, 6. 0. There's only one of those. 4. 1, 2. And finally, 9. There's one of those. Okay? So what I'm going to do is I did tally marks, and I can write out how many times they occur. So there was 5 happened 5 times. Excuse me, 8 happened 5 times. 11 happened 6 times. 12 happened 3 times. 6 happened 6 times. 0 happened 1 time. 4 happened twice. And 9 happened once. Okay, so when we do this, I'm going to put down how many classes. And by the way, this is the data points, right? Or my raw data. And then the frequency I'm going to put over here. Okay, so I'm going to put these in order. I'm going to put 0 first. And then I'm going to put 4 next. Then I'm going to put 6, then 8, then 9, then 11, and then 12. So I have 1, 2, 3, 4, 5, 6, 7 different number of classes, and 1, 2, 3, 4, 5, 6, 7. Okay, now I'm just going to write down what I found with the tally marks. So the frequency of 0 was 1. The frequency of 4 classes was 2. The frequency of 6 classes was 6. The frequency of 8 classes was 5. The frequency of 9 classes was 1. The frequency of 11 classes was 6. And the frequency of 12 classes was 3. So frequency means how many times did that data point occur. Okay. And here's a note. When you see frequency tables in the real world, usually they're done with thousands of data points. So if we have a small amount, it really isn't as great as if we have larger amounts of data. Okay, so this next question we are going to skip because it requires a class to choose 5 movies. So what I'm going to do is just make an X out of this. So you guys can do the same. Just X it out. If I can get the pen to work, we're in good shape. There we go. And I'm going to make this nice. Doing. Okay. And then we're going to move on. So the question reads, why would a frequency table not be useful for the data given below? So let's look at the data and figure out why. A study looked at the ages of lottery winners, and they're given below. So we have 24, 29, 33, 36, 38, 41, 45, 46, 47, 49, 54 twice, 55 twice, 57, 59, 61, 66, 67, etc. The problem with this is when we do the frequency, we would see that most of the ages only had one person in them, with the exception of 54. So our table would be kind of meaningless because we don't have a lot of duplicates of the data points. So again, the only data point that repeated, well, there's actually a couple of them. 54 happened twice, 55 happens twice, and 70 happened twice. Otherwise, they happen once. So it's not really a great example. All right, I'm going to end the 8.1 video. There's going to be, the next video is going to continue on.